So let's have a look at what this monodromy representation looks like for our two functions. For log and for z to the alpha, or in particular for the solutions to zd squared g of z is 0 and zd minus alpha g of z is 0. And well, it's actually not very hard. So as we determined, the solutions to this look like log of z and 1, sort of locally. The solution to this, well, is z to the alpha, whatever that means. All of them are defined everywhere except in 0. Well, I guess the constant function is also defined in 0. Then you can see the domain U is just the complex numbers without 0. And it's not simply connected, but it's connected. So this fundamental groupoid really is sort of equivalent just to a group, namely the fundamental group. And this fundamental group is generated by one element, and this is the path that goes around once. So now what are these monodromies? We start out at 1. So let's begin with our left differential equation. We start at 1. And as you remember, when you go around once, your logarithm sort of acquires a constant thing of 2 pi I. So our path, gamma, under the monodromy representation, is mapped to the map, well, if we take log z and 1 locally around 1 as our basis, then, yeah, let's do it the other way around. 1 is mapped to itself, and the log is mapped to, well, the log plus 2 pi I. So this is our monodromy representation for this ODE. And for this ODE, well, we go around once, and we sort of end up with an extra factor of exp to the 2 pi I alpha. So for example, if alpha happens to be 1/2, we have the square root function, and when you go around the origin once, you end up with the negative square root, because exp to the pi I is just -1. And it turns out that our locally constant sheaf is completely determined by sort of, at least on like connected space, whatever, it's completely determined by this fundamental group monodromy representation. Similarly, if you were to view this as a vector bundle with flat connection, you also get the flat connection. So there is this kind of correspondence.